Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about theta notation. So let's get started. In previous videos I talk about big O notation and omega notation. Big O notation is used to represent the exact and the upper bound of an algorithm, and omega notation is used to represent exact and the lower bound of an algorithm. So what is mean by lower and upper bound? If you have written an algorithm and you have to tell that what is the order of growth of this function, then you can tell in terms of big O notation that exactly my function is going to take this much amount of time, or at max my function is going to take this much amount of time. When we have this type of scenarios, we can use big O notation. Now next, omega notation. So when we use omega notation, when we do not know the upper bound of a function, either we know the exact bound of the function, it means it exactly takes this much amount of time, or we know the lower bound of the function, it means at minimum our function is going to take this much amount of time. If input to a function tends to infinity, then we do not know what happens and we do not know the upper bound of a function, because in asymptotic analysis and asymptotic notations we always consider that our n tends to infinity. We do not care about the small n, right? So this is all about big O notation, omega notation. Now the question is, what if we want to represent the exact bound of an algorithm? Do we have any other notation? Yes, this is where theta notation comes into picture. So whenever you have a situation where you know exactly that my function is going to take this much amount of time, you can simply represent the order of growth of this function in theta notation. So let's see an example. Let's say we have a function and we have an expression of time taken by a function is 2n plus 3. If we have to find the order of growth of this function, then what we have to do? We simply use the asymptotic analysis and the direct method of the asymptotic analysis. What direct method say? Ignore the lower order term. So in this case, the 3 is the lower order term and the highest growing term is n. So the direct method says ignore the lower order term and ignore the coefficient of higher order term. So we are just ignoring 3 and 2. So we get the n, and we can simply say that fn is a theta of n. It means the exact bound of this function is going to be theta of n. Now in this video we are going to see the mathematical definition of this. Okay, so in this video we are going to see the mathematical definition of theta notation. So let's see. So we have a function with the expression of time taken by this function is 2n plus 3, and we have recently proved that the order of growth of fn is equal to theta of n. So here n is the expression of exact bound, right? Because we are using theta notation. So in terms of function, we can represent n as a gn is equal to n, and after substituting the value of n with gn, it becomes fn of theta of gn. Now here is the twist. We can say that our function fn is a theta of gn. This is only true if there exist constant c1 and c2 and n0, where c1 and c2 both should be greater than 0, where n is also greater than n0 and n0 is also greater than 0, such that c1 gn less than fn less than c2 gn, okay, for all the n greater than equal to 0. So what does it mean? Here we are saying that we are bounding this function on both the side. Means this is the lower bound of this function and this is the upper bound of this function, and by using this statement we are going to calculate the exact bound of this function, and here we have to find the value of c1 and c2 and n0 to mathematically prove this statement. So let's see with an example. So we have a function with the time taken by this function as represented as 2n plus 3. We have gn as n. So let's write this statement once again: c1n less than fn n less than c2 gn. Now this portion of statement represent the lower bound, so we can say that the value of cn is going to be 1. Why? Because the time taken by a function is 2n plus 3, right? So we take the coefficient of higher order term and reduce it by 1, so we get 1 here, and this portion of this statement represents the higher bound of the function. So we take the higher order term and take the coefficient of it and add 1 to it, so it becomes 3. So by putting the value of c1 and c2, we get 1 into n less than 2n plus 3 less than 3 into n. So by solving the left part of the equation, we get n is greater than equal to minus 3. and by solving this part of the equation we get 3 is less than n. So overall our n0 is going to be 3. Why? Because see, the n is greater than 0 and here the n is greater than 3. So ultimately our n is equal to 3 cover both the cases. So our n0 is going to be always 3. So let's put the value of C1 and C2 and n0. So we got our values C1 as 1, C2 as 3 and n0 as 3. So let's put all those values in this statement, right, and see whether it is working or not. So let's put the value of C1, Gn, Fn, C2 and Gn. So what is our n0? N0 is 3. We have just calculated it. Okay, so let's put the value of n here. We get 3 less than 5 less than 9. So here you can see that we have proved it, and our left part is less than and right part is greater. It means 3 is going to be the lower bound of this function and 9 is going to be the upper bound of the function. So this is how we mathematically proved it. Okay, if you see order of growth on a graph, you can see a graph like this. So this is our Fn, that is 2n plus 3. This is the lower bound n. Why? Because we took the value of C1 as 1, so it becomes n. So this is our lower bound, and here we took the value of C2 as 3, so it becomes the upper bound. So this is going to be upper bound of the function, this is going to be lower bound of the function, and this is our exact bound. So whenever there is a scenario where you know exactly that how much time your function is going to take, then always prefer to use exact bound. Why? Because if you already know the exact bound, then there is no point of using the upper bound of the lower bound. We are much interested to know the exact bound, right? So when to use theta notation? So again, let's say you have a problem to find the largest number in an array. So to find the largest number in an array, obviously you have to traverse array from first element to last element. Then only you can find the largest number in an array. I'm not considering if an array is sorted or not. I'm just taking the simple example. Let's say your array is not sorted. Okay. The second example, if you have a function to traverse an array from first element to last element, in that case also you know that you have to traverse an array from 1 to last element. If your array has 10 elements, then you have to traverse from 1 to n to traverse all the element. In that case also you can say that the order of growth of this function is theta of n. Okay. Now you have some functions having only mathematical formula, only mathematical calculation, and you are doing constant amount of work. Then also you can say that the function, the order of growth of our function is theta of n. So ultimately we have covered all the 3 notations, and if you have not watched our previous videos, so I highly recommend to watch those videos to understand the big O notation, omega notation and theta notation. So let me recap once again. So what we have learned so far, that if you know the exact bound of any function, then you can use theta notation. If you know exact or upper bound, then you can easily use big O notation. Big O notation represents the upper bound of a function. It means your function is going to take at least this much amount of time, but it may take less amount of time also. In omega notation, it represents the exact or the lower bound. It means it tells that our function is going to take minimum this amount of time, but it depends upon the input. If input becomes large, then it may take the larger number also. It may take more time also. Okay, the order of growth may increase. It depends. So this is all about it. I hope you have a clear understanding of about big O notation, theta notation and omega notation. Thanks for watching. See you in the next video.